Hi guys, this is topic 8.8, the properties of buffers. So, what are buffers? A buffer is a solution that when a strong acid or base is added to it, it's able to resist the pH change that occurs to a certain capacity. This capacity is referred to as the buffer capacity. Buffers are composed of a weak acid and a weak base that must not react with each other. The weak base will react with added H plus protons from the strong acids, or the weak acid will react with OH negative ions from strong bases to resist changes in pH. The greater the concentration of the acid or base, the greater the buffer capacity will be. In addition, a greater concentration of weak acid will mean that the buffer is better at neutralizing strong bases, and vice versa for the weak base and strong acids. What that means basically is that since there's more weak acid, the buffer will be better at neutralizing the OH negative ions from strong bases, and the opposite for more weak bases too. Buffers are most commonly prepared using a weak conjugate acid-base pair. One example of this in this diagram is NH3 and NH4 plus conjugate acid-base pair. So in the diagram on the left, you see an example of when a strong base is added into the NH3 NH4 plus buffer, which is represented by the red H plus ion, which would be the proton from the strong acid. So you see that the NH3 bonds with the added H plus to then create NH4 plus, which neutralizes the pH of the solution, and therefore this buffer is going to resist the pH change that should occur when the proton's added. In the diagram on the right, you see an example of when a strong base would be added into this buffer solution. And you know that because it's an OH negative ion shown being added into the beaker. So you see that the NH4 plus and the OH negative will combine to then form NH3 plus and H2O. So the OH negative bonds with the extra proton in the NH4 to then create H2O, which will neutralize the pH change that's supposed to happen when you add the OH negative. Let's practice.
Okay, so for our practice question, we have a free response College Board question, which reads, a student is asked to prepare a buffer solution made with equal molar amounts of CH3NH2 and CH3NH3Cl. The student uses 25 milliliters of 0.100 molar solution of CH3NH2, which contains 0.0250 moles of CH3NH2 to make the buffer. And then part A says, calculate the mass of CH3NH3Cl solid that contains 0.00250 moles of CH3NH3Cl. So for this one, since it says calculate the mass, we want our answer in grams, which means we have to use the molar mass. So you would have to calculate the molar mass of CH3NH3Cl first and multiply it by the amount of moles that it contains. So by doing that, we can do some simple stoichiometry. So you can say 0.00250 moles of CH3NH3Cl times 67.52 grams, which is the molar mass of the solid, and then over 1 mole. And then if you just plug that into your calculator, you'll get 0.169 grams, which will be your answer for part A.
So this question is asking the following table contains a partial procedure for making the buffer solution. Fill in steps 1 and 4 to complete the procedure using only the materials and equipment selected from the choices given. Not all materials listed will be used. Assume that all appropriate safety measures are already in place. So now what we see here is that steps 1 and 4 need to be filled in, and we already have some of the steps already in here. So what we want to do first is that we want to be able to measure out the amount of mass of CH3NH3Cl that we calculated in our previous solution, as we're asking to make a buffer solution of equal molar amounts. So using this mass that we calculated, We want to be able to use a spatula, balance, and weighing paper to be able to measure out exactly the amount that we need to create the buffer solution. And so now we see in step 2 and 3, and we're placing the solid in a 50 milliliter beaker since this is a solid that we're adding in. And now we're going to clean the beret and rinse with distilled water. Now, when we're making the buffer, we want to be able to rinse the beret with a small amount of CH3NH2 and then drain and then refill it back again with CH3NH2, since the next step asks us to add 25 milliliters of CH3NH2 into the beaker, and it's using a beret. So after this rinsing with distilled water, you always want to rinse it back with whatever you're depositing into the beaker, as there might be some residue from the distilled water that could potentially mess up the contents of the experiment. Now the next question asks the value of Kb for CH3NH2 is 4.4 to 10 to the negative 4th power, and the pH of the buffer the student prepared is 10.64. Now when the student prepares a second buffer solution, the student uses 25 milliliters of 0.05 molar of CH3NH2 instead of 25 milliliters of 0.1 molar of CH3NH2, and half the mass of CH3NH3Cl that was used in the first buffer. Is the pH of the second buffer greater than or less than or equal to the pH of the first buffer? So this would be equal to, because the weak acid to conjugate base is still 1.1. So as we see here, it's 25 milliliters of 0.05 molars of CH3NH2. We're only using half of the mass of CH3NH3Cl. So half the mass will also equal half molars, and half that also halves the concentration. So these two are still in 1-to-1 ratio, which means that the pH of the buffer will still be the same.